So today we're going to be talking about recognizing proportionality, and I like to remember this as simplifying ratios or simplifying fractions to see if they will end up being equivalent. So a proportional relationship can be represented by equivalent ratios. So if we look right here, we know that 1/2 is equal to 1/2. We've talked about a balance beam, and if this equal sign is the center of our balance beam, we need to make sure that both sides are equivalent. So we know just looking at 1/2 and 1/2 that those are equivalent, but we know if we divide 1/2 by 1, because 1 divided by 1 is 1, 2 divided by 1 is 2, we know that we're going to get equivalent ratios. So now let's look over here. Well, they're saying 4/8 is equal to 1/2. And you might be saying, Miss S, 4 is bigger than 1 though, so wouldn't my balance beam look something like this? Well, let's look again at this. Here's our equal sign. So to get from 4 to 1, I divide by 4. And to get from 8 to 2, I divide by 4. So 4 divided by 4 is 1. 8 divided by 4 is 2. So the ratios 1/2 and 4/8 are equivalent. So the ratios 1/2 and 4/8 form a proportional relationship. Essentially, proportional relationship means they're equivalent. So they want to know, does each pair of ratios form a proportional relationship?
There's nothing tricky here. Equivalent ratios form a proportional relationship. You've identified equivalent ratios before, so you can apply those same skills here. Here's another place you're applying the idea of equivalence.
So let's try this first one. If I have 2/8 and 3/12, well, I need to figure out if they will simplify down to the same thing. I know 2/8 are both even, 2 and 8, so I'm going to divide by 2. 2 divided by 2 is 1, and 8 divided by 2 is 4. What about 3/12? Well, 3/12, what can come out of 3 and 12? Well, I know 3 can. So 3 divided by 3 is 1, and 12 divided by 3 is 4. Is 1/4 equal to 1/4? Yes. So that means, yeah, they're going to form proportional relationships. Let's look at B. 1/3, okay, is already in simplest form. So I just need to simplify 3/9. Well, 3/9, 3 divided by 3 is 1, and 9 divided by 3 is 3. Well, is 1/3 equivalent to 1/3? It sure is, so that means that 1/3 and 3/9 also goes here. Okay, let's go on to C. If I have 6/15, well, what can come out of 6 and 15? Well, 15's odd, 6 even, so let's try 3. 6 divided by 3 is 2, and 15 divided by 3 is 5. Go ahead and try 9/18, okay, and freeze it. See what you get. Well, I have 9/18. 9 divided by 9 is 1. 18 divided by 9 is 2. Is 2/5 and 1/2 equivalent? No, they are not equivalent. So I know that they will not go there. So what I want for you to do now is go ahead and simplify 5/20 and 6/24 and figure out if it should go in the yes column or the no column, and why is what I should see in your notes. Go ahead and freeze it, and I'm going to move on. They would like to know which pairs of ratios have a proportional relationship. So we've discussed how proportional relationship means simplifying it down to see if the numbers are equivalent. So go ahead and write these down, and I want you to solve which ones are equivalent. I should see that in your notes. Go ahead and freeze your screen and figure out which ones will simplify to the same number.
A table can show ratios equivalent to 2 to 1. Each ratio can also be represented as a point on the graph. The line represents all of the ratios equivalent to 2 to 1. The line passes through the origin. A table shows a proportional relationship when the ratios between the entries in each row are equivalent. A graph shows all the points with a proportional relationship if it is a straight line that passes through the origin. 0, 0. All of the points the line passes through are equivalent to the same ratio. Equations in the form y equals m times x represent proportional relationships. For example, the equation y equals 1/2 times x represents all the x and y values related by the ratio 2 to 1, or when y is 1/2 x.
So they're showing that the relationship here is as x goes up by 2, y goes up by 1. So you're going to notice here, if we start at the origin, or 0, 0, that we're going to go over 2 on x and 1 on y. So you might be saying, Miss S, why did they flip it? Well, remember your y is 1. So y is where we're starting. You're going to go up 1 over 2, up 1 over 2, up 1 over 2. So any number on this graph that goes up 1 and over 2 from a previous point will be a proportion. So they want to know, does each table show a proportional relationship? Explain. So I need to go over here, and I know that when I am 6, my cat will be 2. When I am 8, my cat will be 4. When I am 10, my cat will be 6. And when I am 12, my cat will be 8. Okay, sorry, that's a bad line. Try and draw a straight line through that. Now let's go over here. When my weight is 4, okay, my water is 120. When my weight is 6, my water is 180. And my weight is 8, my water is 240. When my water is 10, when my weight is 10, my water is 300. So they want to know, are these proportional? And we need to go back to our key concept and look and talk about, what does it mean if something's proportional? The one thing they said is that your line must go through the origin, or 0, 0. So this one, when I drag my line out, it does not go through 0, 0. So no, this one is not proportional to this one that does go through 0, 0. So again, line does not pass through the origin. And this one is yes, because it passes through the origin of 0, 0.
Which table or tables show a proportional relationship between x and y?
So you need to go through and figure out if I put an x value over a y value. So I know I'll have 3/9 here. 3/9 I know simplifies down to 1/3. You need to go through each of these x and y values and see if they will simplify down to 1/3. If they do, then they are forming a proportional relationship. Same for here. If I have my x value over my y value, if x is 5 and y is 2, I need to go through each time and see if they will simplify down to 5/2. Go ahead and freeze your screen and circle the ones that form a proportional relationship. On to part 3. On to part 3. Does each equation represent a proportional relationship? Explain. So with this one, okay, we're going to be looking at the same thing, but it's a little different. 4/3 x means I'm going to go over 4 and up 3, over 4 and up 3. Yes, that's going to form a proportional relationship. But for those of you that might remember a little bit of graphing from 5th grade or maybe some this year, this +3 is saying we're actually starting at a different point. That's telling me that I'm going to start on my y-axis at 3. So from this point right here, they're saying I'm going to go over 4 up 3, over 4 up 3. So, no, B does not work, but A certainly will. And the reason why A is going to work is because it starts in the origin. Does this represent a proportion? Explain. So go ahead and solve this on your notes. Think about what I just talked about on the previous slide about the +3 or not having a +3, what that means, and explain in 1 or 2 sentences why you chose your answer. When you are done, you may go ahead on to your homework.